Creating plants are resilient to stress is a long-lasting task of plant biologists. We now have the knowledge to make crops more resistant to environmental changes, but often this resilience breaks under field conditions. This kind of synthetic biology that we're doing in WISB gives us the opportunity to approach this challenge from a different angle by putting things that we already know together in a new way. For example, provide us with tools to put together multiple desirable traits such as high yields and resistance to pathogens. At the same time, the buzz about synthetic biology has revitalized the interest of people about biology, and particularly plant biology, which can only be a positive thing in my mind.
I'm one of the WISB academics working on engineering bacteria to access pharmaceuticals and agrochemicals compounds. To engineer these bacteria, we are using a combination of techniques which involves bioinformatic tools as well as modern molecular microbiology techniques and analytical chemistry. So we are introducing synthetic pieces of DNA into these bacteria, which are then starting to produce these really high-value compounds, which we can then use as drugs, as antimicrobial drugs or anti-cancer drugs.
The talks today at the launch have really raised a lot of interesting questions about public engagement and about the kind of challenges that synthetic biologists face in bringing their work and liaising with the public and really engaging the public in iterative processes of innovation and design. I'm hoping to design a line of research that investigates and interrogates the kinds of intuitions that people bring to the table when they're thinking about synthetic biology. And a hope would be that this kind of research could not just be of interest to cognitive scientists, but could actually be taken to the public themselves and engage their natural enthusiasm for understanding how they think about their own minds and ask them to really interrogate what they think about when they think about synthetic biology.
Given the amount of public money that's being invested in synthetic biology in the UK and the potential of the technologies that are involved, we ought to see in due course some output, some innovations and perhaps products and processes of significant social benefit. The trouble is that it's actually quite difficult to establish a consensus about what is beneficial socially. So the ethical, social and legal implications work that I'm concerned with here at WISB is all about responding or coming up with possible responses to that contradiction.